Dot and cross diagrams. On the screen you can see a dot and cross diagram. What information do dot and cross diagrams tell you? So if we look at the diagram, we can see obviously it shows the electron configuration of ions. Here's the arrangement of 2, 8. Here the electron arrangement of this 2, 8. And we can also see the charges shown in the top right corner. And just like the formula for magnesium chloride is MgCl, so MgF2, we can see it tells us for every magnesium ion we need to have 2 fluoride ions to make sure that it's the same total amount of positive charge as there is of negative charge. We can also see that we've used dots for 1 ions, electrons, and circles for the other ones, plus any electrons which have been gained look like those of magnesiums, because obviously the magnesium lost electrons which were transferred to 2 fluorines to become fluoride ions. So a quick recap: the information shows the electron configurations of the ions, charges in the ions, and the ratio of the ions to each other. So how do we generate this diagram? Let's start from scratch. So if we look up magnesium and fluorine on the periodic table, we can find out their atomic number. So if we start thinking about this, we know the atomic number, we can work out the number of protons, because the atomic number and the number of protons are the same. For an atom, it will have the same number of protons as it has electrons. And let's start with going from this point here. So we've got our elements. We've said the number of protons is equal to the atomic number, and if we look at the periodic table, it's the smaller number associated with each element. Atoms are neutral, so it will have the same number of electrons as it has protons. The electron arrangement: 2 at most in the first shell, 8 at most in the second shell, and the third shell is happy or stable with 8 electrons. The way I always think about it is, if a number is greater than 10, we have 2 in the first shell, 8 in the second shell, and whatever's left will be in the third shell, so 2, 8, 2. Let's do the same for fluorine: 9 electrons, 2 in the first shell, 7 in the second shell. Again, what we could do from here is think, if we looked at a periodic table, we knew that magnesium had 2 electrons in the outer shell, so when it forms an ion, it will lose 2 electrons from a 2+ ion. Fluorine being in group 7, everything in group 7 forms -1 ions. When these form ions, metals lose electrons, so magnesium will lose 2 electrons, the electrons in its outer shell, to gain the configuration 2, 8. As it's lost 2 electrons, its charge will be 2+. Fluorine has the configuration 2, 7, so to form an ion it will gain 1 electron and obtain the electron configuration 2, 8. As it's gained 1 electron, its charge will be -1. Let's have a look at the picture of those ions. You can see at the moment I'm showing all shells of electrons. Often you only need to show outer shells of electrons. Fluorine, we can see, had its original 2, 7 electron arrangement plus the 1 which is gained. At the moment you can see the charges aren't balanced. We have a 2+ charge, and that isn't counteracted or totally balanced by a -1 charge, so we'll need 2 fluoride ions. So let's do another one. Aluminium oxide. You may want to pause, think about what numbers go in here, and see if you can draw your diagram. So aluminium, 13 protons, 13 electrons. Electron arrangement: 2, 8, 3. When it forms an ion, it will lose the 3 outer shell electrons to obtain the electron arrangement 2, 8, and as it's lost 3 electrons, it will have a charge of 3+. Oxygen, 8 protons, so it will have 8 electrons. The arrangement will be 2, 6, filling in the first shell, 2 plus the remaining 6 electrons in the outer shell. To obtain a full outer shell, which would be 8 electrons, it will need to gain 2 electrons, so becoming 2, 8, and the charge from the ion will be 2-. Let's have a look at a picture of each of those ions. Again, you can see arrangement of 2,8 for the aluminium, the 2,6 being the red circles on oxygen plus the 2 gained ones in the outer shell. You can see the charges again shown here. Now we could carefully work out how many of each ion we need to balance it. So we've got 3 plus and 2 minus. We still need some more negative ions. We now have more negative ions than positive ions, so we now add some more positive ions. So we've got 6 positives which aren't counteracted by 6 negatives, so we'll need a third one. This would take quite a long time to draw, so there's obviously a way we could shortcut this. Can you think how this would be shortcutted? In the same way that when we write formulae, we put numbers in the bottom right hand corners, we can also do this for diagrams for ionic compounds. Draw a dot and cross diagram for calcium chloride. Calcium is a group 2 element and chlorine is a group 7 element. Pause the video and then you can see the solution in a second. Calcium is in group 2, so it is going to form ions with a charge of 2 plus. Everything which is a metal ion, which will have a full outer shell, will have 8 electrons in the outer shell, apart from that of lithium. It's lost 2 electrons because group 2 elements form ions with a charge of 2 plus. If you weren't sure about this little step, you could always write the electron configuration of calcium as 2, 8, 8, 2. So we can see the penultimate shell, before any of the electrons in the outer shell which were lost, had 8 electrons in the outer shell. Chlorine, we know, is in group 7 of the periodic table, so it will have 7 of its own electrons in its outer shell, which we're going to represent as dots. We know it's gained 1 electron to obtain a full outer shell, like so. As it's gained 1 electron, its charge will be -1, and to balance out the charge, we need to have, for every 2 plus ions, we'll need to have 2 -1 ions, like so. So that is your solution there. The next one we're going to do is going to be draw a dot and cross diagram for sodium oxide. Sodium is in group 1 and oxygen is in group 6. Pause the video, then push play when you think you've got an answer. So starting off, sodium is in group 1, so that means when it forms an ion it will lose 1 electron from its outer shell to form an Na plus ion. And as sodium is a metal and not lithium, it will have 8 electrons in its outer shell, like so. Oxygen is in group 6 of the periodic table. That means it will have 6 electrons in its outer shell. 1, 2, 3, 4, 5, 6. And to obtain a full outer shell, it will gain 2 electrons. These will have come from sodium atoms. As it's gained 2 electrons, its charge will be 2 minus. Obviously it should just be about here, but I've obviously put it slightly in the wrong place. So in terms of charge, we've got a plus here and a 2 minus here, so we have not got the same amount of positive and negative charge, so we will need to have 2 sodium ions rather for every oxide ion. Here is a nice neat version of that diagram. The next challenge is going to be aluminium bromide. Aluminium is in group 3 and bromine is in group 7. With this one here, if you try to write out the electron configuration of bromine, you'll get probably a very strange answer, but as we know it's in group 7, we know it has 7 electrons in the outer shell. So let's start off. Aluminium is in group 3, so that means it will form ions with a charge of 3 plus. As it's not lithium, it will have 8 electrons in its outer shell, like so. Bromine is in group 7, so it's going to have 7 electrons in its outer shell, and we're going to try changing the colour of ink, being a bit more advanced here. So here's bromine with 7 electrons in its outer shell. It's obviously going to gain an electron. So the electron it's gained has come from aluminium. So that means it's got 1 cross in the electron configuration here. As it's gained 1 electron, it has a charge of -1. Now we've got a 3+ ion and a minus, so that means to balance charge we will need to have 3 negative ions to balance out the 3+ charge. So we've got 3 bromide ions for every aluminium ion. And here is a diagram which shows it nice and neatly. The next one and final one is aluminium oxide. Aluminium is still in group 3 of the periodic table and oxygen is in group 6. You've actually drawn ions for both aluminium ions and oxide ions, so hopefully this should help. So if we think about doing this, we start off with the aluminium ion which we've just drawn. Aluminium is in group 3 of the periodic table and it's not lithium, so it will have 8 electrons in its outer shell like so. As it's lost 3 electrons, because group 3 metals lose 3 electrons to obtain full outer shells, it will have a charge of 3+. Oxygen is in group 6 of a periodic table, so that means it will need to gain 2 electrons to obtain a full outer shell of electrons. So it has its 6 electrons in its outer shell here. It's going to gain 2, which we'll draw in a second, and it's got a charge of 2-. So let's just add on the electrons now for the aluminium, which it's gained. Now the charges don't balance, and we can just use swap and drop. So that number there is not a 1, so we can write it down here. And that's a 3, so we can write it down here. So we have a 3 down here. You'll see that number there will match that number there, and if it's a 1 we obviously don't write it in. And then obviously let's change the pink pen color again to our purple. The 2 up here, that's when using swap and drop, that 2 will end up down here. So there's our dot and cross diagram for aluminium oxide. I hope this tutorial has been helpful. If you have any suggestions or improvements, please do let me know.